Yeah.
What's up, mathletes? It's Math Life here, and boy, we got a surprise for you today. We are talking about graphing systems of equations and figuring out how to solve them. I got a special guest mathlete for you. Let's bring him in.
What's up, mathletes? Mr. Hoffman here. Hey, we're going to get right into it. The question is, how do you solve a system, two equations, by graphing? And let's look at example number 1 here. We've got y equals x minus 7 and y equals negative 4x minus 2. And the question is, what is the solution for both of those equations? Well, hey, we can do this by graphing, okay? Let's look at equation number 1. The question is, what is your slope and what is your y-intercept? Well, hey, remember, there's an invisible 1 in front of this x, which means my slope, my rise over run, would be 1 over 1. And my y-intercept, or my initial value here, negative 7. And I'm going to go to my graph. I'm going to plot negative 7. And from that point, I'm going to go up 1 over 1. And I'm going to do that a bunch of times here. Up 1 over 1. Okay, and once you have all your points on, I'd like for you to pick up your straight edge and graph your line. Okay, now let's go to equation number 2. Y equals negative 1/4 x minus 2. Hey, my slope here is negative 1/4. And my y-intercept, or my initial value, is negative 2. Okay, we're going to find negative 2. And from that point, guys, it's a negative 1/4. So I'm going to go down 1 over 4. Okay? And I actually, instead of going down 1 over 4, I could go up 1 and left 4. And notice this forms a straight line. Pick up your straight edge. Now, the question is, what is the solution for both of these? And if you remember in our exploration, we're looking for the point at which these two lines intersect, okay? And that ordered pair would be 4, negative 3. This is the only solution that will work for this equation and this equation.
All right, coming back at you, we're going to solve problem number 2. Number 2 is y equals negative x plus 4. I know there's a little dash here, but that's really what it is. So let's try to find the m. In this case, remember we talked about there's an imaginary 1 in front, but in this case it's a negative x. So negative 1 over 1 for our m. Our b is going to be plus 4. All right, and we're going to graph that one. So let's start graphing that one with our blue. So we start at positive 4. It's negative 1 over 1, so we're going to go down 1 and right 1. And follow the pattern, down 1, right 1, down 1, right 1. Continue the pattern till we reach the end. And we want to plot some points over here, or some solutions up here, so we're going to go the opposite direction. Instead of going down 1, right, we're going to go up 1 and left, and kind of follow that pattern until we reach the edge of our coordinate plane. Pick up your straight edge, connect all the dots, and draw our arrows at the end because it extends forever. Let's look at number 2. Number 2, the m is negative 2, but remember it's negative 2 over 1, and our b is positive 8. So let's start here at positive 8 and follow our slope down 2, because it's negative, and over 1, so 1, 2 over 1. Continue the pattern, down 2 over 1, down 2 over 1, down 2 over 1. Let's do it one more time. Actually, we can do it one more time there. And let's connect all the dots with our straight edge and draw arrows at the end. And as Mr. Hoffman said, we are looking for the solution, or where they intersect. In this case, they intersect right here. And that is the order pair, negative 4, positive 4, see if you're paying attention, positive 4, comma 0. Right? And that is the only place that these two lines will intersect. So one solution. All right, let's bring it back to Mr. Hoffman to get you the next part.
Okay, so the next example here is y equals 2x minus 5 and y equals 2x plus 1. And something should jump out to you right away. Yeah, if you look at both of these equations, they both have the same slope. Okay, now, how is that going to affect our solution? Okay, well, let's graph both equations. For this first equation, we know the slope is 2 over 1. And we know the y-intercept, or the initial value, is negative 5. Okay? And I'm going to do that in blue, down to negative 5, up to right 1. And I'm just going to continue that pattern like Mr. Stauffer said. And I can actually continue that pattern going up and to the right and down and to the left. And once you have the pattern or your points in a straight line, we're going to graph our line. Okay? Now, second equation, notice our slope, 2 over 1. But what is different about this equation? Well, yeah, it has a different y-intercept, or initial value. It has a y-intercept of 1. Okay? So now, I'm going to go plot 1, and then up to over 1. We do that going up and to the right. I could also do that going down and to the left. Okay. Take your straight edge, graph a line. Okay. Now the question is, what's the solution? Well, in example 1 and 2, we found where these two lines intersect. But if you remember back from our exploration, there was a point where they would never have the same amount of money. Okay? Well, look at these lines. Are these two lines ever going to intersect at a certain point? And the answer is no. They're actually what we call parallel lines, and they're parallel because they have the same slope. So what is our answer here? Our answer here is no solution. There is no ordered pair that would work for this equation and work for this equation. Okay, last example here, Mr. Stauffer.
All right, so if you're thinking about the exploration, you had the no solution, you had one solution, and hopefully you're looking at these two examples and something should jump out to you for this one. If we look at this one, the first one, the m is slope, so it's 3 over 1, and the y-intercept is 2. So again, we're going to go our graph, find 2, and then use our rise and run. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. And then follow the same pattern doing the opposite way. Down 3, 1, 2, 3 over 1. And so forth till we reach. We can't make more points. Don't forget, connect them with your straight edge. And there's our first line. Our second line, our m, guess what? It's also 3 over 1. And our y-intercept is 2. Well, you're probably thinking something, or maybe you're not thinking, but let's talk about how we think about this. They have the same slope. So I'm just going to kind of graph it with a red here and start at 2. And, they have the same y-intercept too. So let's go up 3 over 1. Oh, we met again. Up 3 over 1. Oh, met again. Let's go back down the other way. And if we follow that, notice that they actually overlap. And if you didn't notice before, that they're the same line. So they actually touch an infinite amount of times. And that every point on here is going to be a solution. So what does that mean? Well, that means we have infinite solutions. Right? That means we have all the numbers on these lines are going to work to make these equations true. All right, so if you enjoyed this video, don't forget, smash that like button, hit the little bell, ding, don't have it for notifications. Love math. Math you later. Peace. You want to say something, Mr. Hoffman? One. Come on, outro him out.
Ding, hit that button. Bye.